Okay, this is Math200. We're looking at Chapter 9. We're going to finish off 9.7 and 9.8. So let's get the party started here. This is just calculator problems, really. These three. Log, L-O-G, on your calculator means log base 10. And so they want, that's also known as, I think, the common log is base 10. Natural log is base E. E is a non-terminating, non-repeating decimal like pi, an irrational number. They use it in finance a lot, the E, not the base 10. All right, so now, so 10 to what power is 10,000? You can just put that in your calculator. Hit the LOG button and then 10,000 and then hit enter and it should say 4. And the LOG button, that's log base 10 of 1/1000. That's going to be -3. And that's going to be 1/2 or 0.5, sorry. On your calculator, it'll be 0.5. If you roll 1/2, that's fine. So 10 to what power is 10 to the 1/2 power? Well, that's 1/2. All right. Let's do this one. Solve out to 4 decimal places. Okay, so look, we have to know that LOG is base 10 in order to do this problem, because now we're going to rewrite it. And this was a trick that I used about rewriting logs all the time. I knew this. Log base 10 of 100 is equal to 2, right? Because 10 squared is 100. So then you just take these three numbers, 10, 100, and 2, and write them as an exponential. So 10 squared equals 100, right? That's how it's got to play. And now you kind of have framework that number is always the base, that number is always the exponent on the base, and that number is always the one that gets scooched over to the other side. So look, if I do that here, 10 to the 1.3 is equal to 3x. And then you just do that. You execute 10 to the 1.3 divided by 3. And you get 19.9526. 4 decimal places. All right. Okay. Let's look at ln is log base E. So those darned finance people took our beautiful math to make money. And they use the natural log anytime they're finding compounding interest continuously. And so we could do that in your calculator. You could do ln of e to the 4th. That would just be 4, because ln is shorthand for this, log base E. That's what's going on there. So we could do that 2 ways. We could pull the 4 down and say log base E of E is 1, and 4 times 1 is 4. Or we could just say, hey, look, E to what power is E to the 4th? That's 4. Or you can put it in your calculator. ln of the 3rd root of E. So really what's going on here is this. Log base E of E to the 1/3 power. So that's just 1/3. If you did it on your calculator, it would hit out, if you did ln of the 3rd root of E on your calculator, it would say 0.33333, repeating, which is 1/3. All right, let's look at solving an equation with E. ln of 2x plus 5 is equal to 3.4. So look, this is log base E of 2x plus 5 is equal to 3.4. Remember, log base 10 of 100 is 2. 10 squared is 100. So if I want to take it out of a log, even if it's base E, I just follow this pattern. So E, the 3.4 power, 2x plus 5. Your E button on your calculator is second, and then ln, and it'll be e to the x. And we'll let you put it in 3.4. All right, and then we subtract 5. So we get e to the 3.4 minus 5. And then after you do that, you divide everything by 2. And so I suggest waiting to the end to do the e to the 3.4, because it's going to be a really ugly number unless you want to write 12 places 3 times throughout the problem. So do this Subtract 5, hit enter, and then divide the result by 2. And you should get 12.4821 as your answer. All right, and there it is, PERT. That's compounded continuously. Business people use that all the time, the natural log, all the time. So we got A equals P to the times E to the RT power. And so they give us this problem. You got $2,200 at a 6% compounded continuously. So that is 2,200. E is just E on your calculator, and then to the 0.06 times 4 power. And so if you're clicking this into your calculator, do the 0.06 times 4. Trust me on that. That's 0.24. Do that first. So 2,200 E to the 0.24. Type in E, second ln to the 0.24 power, hit enter, and then just hit times 2,200. And so that'll give you that big long decimal, and then times 2,200. And it's $2,796.75. Okie dokie. Let's take a look. Approximate log base 5 of 1/6. Oh, to 10 decimal places. Okay. So look, there's what's called the change of base formula. We're on page 25. So log base B of A is equal to log base C of A divided by log base C of B. So your calculator only has base 10 and base E. But we want to do different bases. What if I want to do a different base? What if I want to find the log base 5 of 1/6? Well, then I have to do this change of base formula, which is actually pretty easy. It's just you do log base 10 of 1/6 divided by log base 10 of 5. So see what happens? And your calculator, that looks like this. Log, just LOG, and then you got a parenthesis that pops up. You do 1 divided by 6, end parenthesis, divided by log, and it'll pop up a parenthesis, 5, end parenthesis, and then hit enter. Do not forget this parenthesis, or you will get the wrong answer every time. You got to remember to chop it off so it's the log divided by the log. All right? And, that works out to be that first top log is 0.69897000043. And that bottom log, log of 5, is negative 0.7781512504. And when you divide those, you get negative 0.8982. Now, you can enter it all in one shot like this and not have to write those down. But if you make mistakes on that often, then write them down, because I don't want you to make a mistake. All right? And then we're going to do 9.8 also. There's only a couple of problems on 9.8, so we're going to do that on this lecture. Solve for... Four to the x is equal to 7. So what we do is let's write this as a log. Remember, log base 10 of 100 is equal to 2. 10 squared equals 100. So that means I can go from this back to that if I need to. And I need to. So look, I want 10, that's my base, log base 4 of 7 is equal to x. So we do that. And so look at what happens. We have, we do the change of base formula, log base 10 of 7 divided by log base 10 of 4. So log 7 divided by log 4. Remember to put the parentheses on them. That turns out to be 1.4037. Oh, also, I'll show you another way to do this. A lot of students didn't like that way, like just writing it, converting it into a log. If that's confusing you, you can do it another way. You still got to use a rule of logs. You could do like what they call take the log of both sides. You throw a log in there, a log in there, and then you pull this down. So you get x log 4 equals log 7, and then you divide out the log 4. That's just a different way of looking at it. Personally, I think it's more steps than just knowing the sequence to move it around. But if you look, they had log 7 divided by log 4. That's what we had there too. So either way, you're still going to get 1.4037. All right. Let's look at number 1. We got log base 4 of 8x minus 6 equals 3. And this looks like a lot harder problem than it is. Because look, I could take 4, just take it out of the log like that. Use that thing. 4 to the third power is equal to 8x minus 6. Well, 4 to the third power, that's 4 times 4 is 16, 64. And look, now we're back to week 1. Add 6 and divide by 8. And we get an ugly answer. But they're not all going to be pretty answers, are they? So 70 eighths I can reduce to 35 fourths. Goop. Or, you know what, if you just told me 8.75, that's fine. You could tell me 8.75 if you wanted to do a decimal on that one. All right. Okay, let's look at the last page. Finally, the last page of notes that you're going to get from Mr. Pledgey in this class. Except for the review. The final review. I'm still going to do a video on that. So here, number 2. Log base 6 of x squared minus x is equal to 1. So how do I do that? Well, that's 6 to the first power is equal to x squared minus x. And so look, that's x squared minus x equals 6. Move the 6 over. Bust out your sweet factoring skills. Multiplies to be -6. That's -1 and 6. -6 and 1. -3 and 2. -2 and 3. Gotta be this one. So x is equal to 3 and x is equal to -2. But we better check those because you might get, whenever you're working with logs like that, you might get some nonsense answers. So especially when the factoring was involved. So I pop a 3 in. I get log base 6 of 9 minus 3. That's log base 6 of 6, which equals 1. So that one works. I pop in -2. Let's see what happens there. Log base 6 of -2 squared minus -2. Does that equal 1? Oh yeah, that's going to work. 4 plus 2. That's 6. Log base 6 of 6 is 1. They both work. Look at that. I was worried for nothing. Let's look at 3. We got log base 4 of 10 minus log base 4 of x equals 2. So remember, minus in log land with like bases like that, it's log base 4 of 10 over x. And now let's write it without. And we've got 4 to the second power is equal to 10 over x. And then cross multiply and solve. So we got 16x equals 10, right? 4 squared is 16 times x, 16x. Divide by 16 and reduce it 5/8. Oof. Again, if you wanted to tell me what's 5/8, 5 divided by 8 is 0.625. That's fine. If you told me 0.625, that's fine. That's fine. That's fine. All right, let's get the last 2 problems, application problems. y is equal to y naught e the 0.15 t. And then they just plug and chug. Oh, thank goodness. So the null, the beginning population is 2,000 lemmings. E to the 0.15 after 8 months. Time is in months. And so you multiply that out. Do yourself a favor, multiply that out. That's 1.2. 2,000. And then if you want from here, you don't have to find e to the 1.2 and write it out. You can just do 2,000 times e, that second ln to get e to the x, and then put in 1.2 and paren, hit enter. And we're looking at 6640. 0.23385, but we'll round to the nearest lemming. 6640. All right. How long does it take an investment of $5,000 to double? Well, let's see. A is equal to P, 1 plus R over N to the NT. So they gave us $5,000, and they want that to become $10,000. And 4%, so 0.04. And compounded quarterly, that's 4 times a year. Quarterly, quarters, 4 quarters at $1. And so 4 up there, and we don't know time. We're going to find time. So look, a lot of stuff we can simplify here. Divide both sides by 5,000. So regardless of the money amount, that they could have said 100 million, and then this would have been 200 million, it's going to end up 2 and 1. So we could have just disregarded the amount. It's easier for me to demonstrate like this, though. So I did it like this to the 4t. Now look at what we got. Look at what we got going here. Right? We got a weird base, 1.01 to the 4t is equal to 2. Let's write it as a log. Log base 1.01. That's a really weird base, right? 2 is equal to 4t. And then just divide by 4. So let's hold off on dividing by 4. Let's take care of this log first, and then we'll divide by 4 last. All right. So what are we going to do there? That's going to be, we write it up here. We got 4t is equal to the log base 10 of 2 divided by the log base 10 of 1.01. And whatever we get there, we're going to divide by 4. And that'll be our answer. Log of 2, end parenthesis, divided by log of 1.01, end parenthesis. 69.66071 divide by 4. Divided by 4 is 17.415. And so we're looking at about 17.4 years. 17 and a half years, you'll double your money with that investment. All right. Okay, that is all of Chapter 9. I hope that was helpful. There will be a couple on the final exam, and I'm going to do those on the exam review. Oh, and a quick Star Wars tidbit. The actor that played C-3PO was the only one that was in all 9 movies. Oh, and I just kicked it. Have a good day.